All right, so we're gonna go through sort of the GI landscape, as well as some angiology, some blood supply. Gonna help you try and take a different approach, sort of create this turn-by-turn navigation system as if you were driving somewhere. I'm on the road right now. We're traveling, doing 8 different states here. And it kind of got me thinking about how to approach blood flow, and just sort of thinking about your starting points and your destination. And that's really what I was trying to get you guys to focus in on for blood supply. Really think about the different functional regions of the gastrointestinal tract, right, or the alimentary canal, and use those different regions that you're already familiar with, and in diving further into detail on the functional regions, and then just use what is the most important thing, right, is those functional regions, and use that as an endpoint for which vessels are carrying blood supply to those endpoints. So we'll kind of start out with a quick little review on just our GI here. Right, so you start out, you got that esophagus, of course. We'll kind of draw in our diaphragm here, sort of oddly shaped. That poor dog with that oddly shaped diaphragm. All right. So, of course, that was your esophageal hiatus, right? Draw in our little stomach here. Of course, as you're going through this, remember, pay attention. You know, your cardia, your fundus, your body, right? Your antrum, your greater curvature, your lesser curvature, right? Kind of coming together here with a little bulge, and that's our pylorus, right? And then we're going to create our cranial duodenal flexure, right? Our descending duodenum, our caudal duodenal flexure. Right. And we're going to have to stretch some things out here in order to give enough space to kind of feel out all of the different regions. Right. And then we're going to turn up. And of course, this is going to be our duodenojejunal flexure, right? And this over here becomes our ascending duodenum. Right. And then now we're into the jejunum, and we're going to leave a little space here, and things are going to get a little shifted in order to see things, right? But now we're into jejunum, and then we're just going to draw in some loops, right? Kind of going like this, coming around. For the most part, you're usually seeing at least one turn in that jejunum, right? As we come down. And then we got this straight section, right? So this is going to be all jejunum, right? And now our straight section, we've got our ilium. Remember, pay attention to spelling here. We don't often ask you to remember spelling, but E for you, right? GI tract, EWW, right? The ILIUM is the bone. Then we've got... and I'm just going with the flow. I was going to try and keep different colors. So let's keep our stomach as this whatever blue color that came out. And then I was going to change, like you can see the difference here, huh? That was going to be our small intestines. All these colors are looking the same. What color is that? Oh, that is blue. But it looks green. Sorry. I don't know why all these colors look the same. All right. Well, so ilium then, right, of course, we've got this funny blind pouch. Well, now that's a different color. Is going to be our cecum, right? And then, right, right? Since it's a blind pouch, I can just close it off. And then let's draw up. Now, in order to make this work out, our ascending colon gets all stretched all the way up here because we've got that duodenocolic fold, right? Remember, that connects the two here. But then we come over here, right? We've got our transverse, we've got our descending, right? And remember, this is taken a turn by your liver, which I'll draw in, and this is taken a turn by the spleen, so we have a couple names there. And then, of course, our rectum, right? Let's see, so we've got some lobes of liver up here. Don't pay attention to how this looks, right? We're just trying to develop that three-dimensional image of the viscera in your mind so you know where things are at, right? So let's call this liver, right? We've got also, right, kind of down here, we've got that chewed gum organ, right? That's going to represent our right lobe and our body. And then what you can't see is, because it's going to lie a little dorsal to our stomach, is going to be our left lobe of our pancreas, right? So we've got pancreas and kind of up over in here too, right? Okay. You already know the functional regions, right? So now we just want to start thinking about the blood supply that's getting us to there, right? In the same way, you may have, make sure we can see this here. All right. In the same way, we may have started out by drawing a map to somebody with different landmarks. We'd say, okay, right, we've got a building here, right, with a house, right? This is going to be our main house road, and because the road is in front of our main house, so we're just going to call that main house road. All right. You take that, if you're describing to somebody how to get from point A to point B, you may say, I want you to get to Apple Tree Lane. Well, Apple Tree Lane is called Apple Tree Lane because there's an apple tree on it, right? But I don't want you to take that road that goes to Crooked Creek. I want you to take Main House Road past Crooked Creek, and you're going to take that to, Apple Tree Lane, right? Same kind of thing is gonna rule the nomenclature. So we're really just trying to understand how the blood supply is getting to what we already know the names of: our stomach, our duodenum, our jejunum, our ileum, our ascending, our transverse, our descending, and our rectum, right? So landmarks, right? So if we wanted to create a full turn by turn, how that corpuscle is making its way down to each segment, of course, we'd start with our heart, right? So we got our right side, right? And then we're going to our lungs, and we got our left side, and then we're going to make our way out, and we're going to come down the aorta, right? So turn by turn, right? We would say avoid, right? You're going to come out of the heart, but I don't need you to take internal thoracic or costocervical trunk or vertebral or your superficial cervical artery, right? Those are our main ones off of our left subclavian. I also want you to avoid brachiocephalic trunk, right? So you're coming out of the heart. Don't make those first two turns. We're now going to go into descending aorta, and as soon as we go through our aortic hiatus, we're now in abdominal aorta, right? So first big landmark, we've crossed the diaphragm. We're officially into our abdominal cavity. All right, so another landmark that you would start to look for the start of our blood flow to the GI is going to be that left crus of the diaphragm, right? So the left crus, right? That's basically the point at which our celiac artery and our cranial mesenteric artery, right? Right? Don't pay attention to my chicken scratch, right? So another big landmark, we're gonna have that left kidney, right? Kind of in the same region, which also means that we've got in our small animal, our phrenico-abdominal artery, right? Which is sort of running off that aorta, and that's where your adrenal gland is usually found in small animal, right? So basically, first of all, we've got, again, our descending aorta, and let's start with our first turn-by-turn with that celiac artery. We've essentially got three options from there. We can go one to our stomach. We can go, let's draw in our spleen here. We can go one to our stomach, we can go two to our spleen, or we could continue on dorsal to our stomach up to our liver, right? So first turn by turn, how do we get to the stomach? We leave the heart, descending aorta. We're gonna take a right turn at celiac, right? And we're gonna take our first turn and go to the gastric artery, which ultimately, if you remember, is gonna be serving the left side, and specifically is gonna be our lesser curvature, right? Beyond the gastric turn, you have an option to take the splenic artery, right? So one turn could be gastric, the other turn is splenic, right? And of course, splenic artery is gonna take you to the spleen. That's why it's named splenic artery. The other option, once we get to the spleen, is we could continue on and then go to our left epigastric. Right, so we've got splenic, right? And then we go to our left epigastric. All right? And that, of course, remember, is going to the greater curvature because it's a bigger name. Okay, so we had, first option was gastric, right? Second option was splenic, right? Our third option was to continue on and go to our liver. So now the liver, you have a couple options, right? Of course, it's called the hepatic artery. So it's, as you would expect, gonna be delivering blood to the liver, structures of the liver. The other option to go to, besides going to the liver, is gonna be to continue on going to the cranial part of our abdominal structures, right? So other option there, right? We had hepatic. So those are the three options. Now, once your hepatic artery actually delivers blood to the liver, right? There's no reason to continue calling it the hepatic artery, and it becomes the duodenocolic artery. Sorry, the gastroduodenal artery. Sorry. Right. The gastroduodenal artery is going to be in the cranial part. Yeah. Gastroduodenal artery is going to be in the cranial part of the abdominal cavity, and it has the option of going to either the stomach or the duodenum, as the name implies, gastroduodenal, right? It's first going to send off some arteries to the now right side, right? So then we go to right side of stomach, which is going to be the right gastric and the right gastroepiploic. Right? Once our arteries come off for the stomach, there's no need to continue having gastro as part of the name. Now that becomes the cranial pancreatico-duodenal artery. So again, we had celiac, gave us options of gastric, splenic, which that then also became left gastroepiploic, or we had hepatic, right? Which basically gave us also our right side gastric and gastroepiploic, and then gave us cranial pancreatico-duodenal, right? Don't need you to really remember gastroduodenal name change between the hepatic and cranial pancreatico-duodenal and the right gastric. Celiac, gastric, splenic, gonna beget the left gastroepiploic. Hepatic, of course, goes to the liver, but also giving you the right gastric, right gastroepiploic, and the cranial pancreatico-duodenal, right? Next option was our cranial mesenteric artery, right? So now we're back over here to our other branch going down this way. So your cranial mesenteric is going to do a couple things, right? First of all, we know that because its name is cranial mesenteric, it's going to be going to the cranial part of our mesenteric structures, right? That mesentery, remember, is that strong layer of connective tissue, primarily that's really tethering our jejunum down to the dorsal body wall. But so first, we know we've got jejunals, right? That the jejunum, remember, is constituting more than half of the length of our entire GI tract if you're going from stomach all the way to exit. So that's going to be basically our first option that's coming off of cranial mesenteric. Right? We then also have another one that's coming off, the ileocolic. Because again, we're thinking about, this is sort of our cranial division, this is kind of our middle division, and then we'll talk about our caudal division, because we basically have three major arteries, or three parent arteries, that are coming off the aorta. And again, we want to think about the destination as well as where we're starting, because we already know where they're ending, and that's really just going to help us pull that nomenclature forward. So as the name implies, it's going to be going to the ileum and structures of the colon, right? Now, knowing the flow of digesta through your alimentary canal, we know that there's a structure that actually lies between the ileum and what we commonly refer to as the colon or the large intestines, right? And so that we know is going to be going to the ileum and the colon and what's in between, which is our cecum, right? So we've got our jejunal arteries coming up to our jejunum, and then we have another artery that's going to be going to the ileum, the cecum, and the colon, right? Ileocolic, we know that, right? So we're going to have the colon part of that is going to be our middle colic and our right colic artery. And our middle colic is going to be going down over here to our transverse colon, right? And our right colic is going to be going down to our ascending colon down here, right? And then also, as the name implies, our cecal artery, guess what, goes down to the cecum, right? That's still off of ileocolic. Right? Now, that cecal artery is going to give you part of our blood supply, right, which is coming in. We've already talked about the colon part of ileocolic, right? Cecal just happens to not be in there because I think ileocecal colic was probably voted out by some old white guy at the nomenclature committee, right? But so your cecal artery is actually what's going to give you, just in small animal and variably present in our bovids, that's going to be that anti-mesenteric artery, right? Which is going to be going up to the anti-mesenteric portion of the ileum, right? Now, at the same time, we don't really ask you to remember, but your ileocolic artery actually gives off a mesenteric portion that goes to the ileum, right? But we only talk about the anti-mesenteric artery because it's so distinctive of a landmark to tell us where we transition from jejunum to ileum, right? So, right, now we've got our colon part and we've got our ileal part, but your cranial mesenteric also is servicing from the caudal aspect the same parts of the duodenum and the pancreas that we saw being serviced by the cranial pancreatico-duodenal. And so that basically your cranial mesenteric, right? Again, if we're doing turn by turn, right? So you're going to bypass celiac and then you're going to take a right at your cranial mesenteric. Now you've got those couple of options. You can either take the jejunal artery, which of course is going to take you to the jejunum, right? Or you could take to the ileocolic artery, which is going to take you to the portions of the ileum, cecum, and the colon, right? Now, if you don't want to take either of those two turns and you continue on, you basically become caudal pancreatico-duodenal, right? So basically, again, turn by turn, right? Descending aorta, we had celiac. We had a couple options. We could take gastric, which took us to the left side of the stomach. We could take splenic, which of course took us to the spleen, but then also had the option of taking us to the left gastroepiploic, or we could have taken the hepatic, which would of course take us to the liver, could have also taken us to the right side, gastric and gastroepiploic, or then continued on and taken us to the cranial part of the duodenum and the cranial part of the pancreas. Or if we bypass celiac, we would have had cranial mesenteric, right? A couple options there again. We could have taken jejunal, which of course would have taken us to the jejunum. The ileocolic would have taken us to through the middle colic artery to the transverse colon, or the right colic artery to the ascending colon, or from the cecal artery off of that would have taken us by means of the antimesenteric artery through the cecum into the ileum, right? Or we could have continued on, and that cranial mesenteric artery would have ultimately become the caudal pancreatico-duodenal artery. All right, so big landmarks again for that were going to be your diaphragm, officially making us abdominal aorta, your kidney, of course, right? Now, lastly, we've got our caudal mesenteric, right? And that becomes a little bit easier in our caudal division. We've really just got two options. We can give off our left colic artery or our caudal rectal artery. So our left colic, right? And that is going to be going to descending colon, or our cranial rectal, which of course is going to the rectum. So again, kind of think about this as turn-by-turn navigation of how you're going to be getting from the heart to whichever region of the GI tract you're wanting to think about. Now, like a lot of roads, as we travel across country, you can either take the main roads, right? Take the interstates, and that gets you a direct route. Or you can take the scenic byway, right? Or do a blue line trip where you only take state highways or the back roads. That would be an example of what we call collateral circulation. So as we've talked about, it's not a redundancy that we see because of surgery, but surgery is able to take advantage of that. It's a redundancy so that there is an overlap of blood supply, because this is a pretty important process, digestion, gaining food and energy to grow and reproduce, right? So you have collateral circulation between the left and right sides of your stomach. So between your left and right gastroepiploic, there's an anastomosis. And between your left and right gastric artery, there's anastomosis. And there is no dead zone between the two sides. Your right side and your left side are going to communicate completely there, barring any trauma, any ischemic events, any surgeries, things like that. But arteries will grow in response to trauma and insults. We have also the overlap between our cranial pancreaticoduodenal, which was off of celiac, right? And our caudal pancreaticoduodenal, which was off of our craniomesenteric, right? So there's overlap there. And then likewise, between our middle colic and our right colic and our left colic artery, we have anastomosis. So there's 3 collateral circulatory loops, right, between our stomach, primarily our entire small intestines, but we really talk about cranial pancreaticoduodenal and caudal pancreaticoduodenal, and then our colic arteries. Right? And I know we're getting a lot of lines here, so you're probably going to be relying a lot on the audio, but really what I would hope for you to be able to do is to then draw this out for yourself. But let's talk about your innervation real quick. We're really just talking about right, our vagus and our sympathetic chain. Right? And we always have to rest and digest after vacationing in Vegas, right? So we know that this is para, which means, oh, well, that already told us it was sympathetic anyway, but, right? So your sympathetic chain, that is what we saw a little bit in vital circuitry, those paravertebral ganglia that came down in a chain-like fashion. Right? And then as we are crossing, our diaphragm sends off our greater splanchnic nerve, which really runs along in 2 ganglia centers here. And collectively, we call that the celiaco-mesenteric plexus. Mostly because it's really hard to distinguish between the various nerve fibers, right? Now that from here essentially is going to distribute to the cranial part of the abdominal cavity. And then we also have a slightly less appreciable grossly, we have our caudal mesenteric plexus, which of course lines right alongside our caudal mesenteric artery. These can be defined as a celiac ganglia and craniomesenteric ganglia, but again, in most specimens, it's really hard to distinguish So a lot of times we'll just refer to them as that celiaco-mesenteric plexus. All right, so that's one option for our fight or flight, right? Which really is just inhibiting as far as the GI function. Your sympathetic is really primarily inhibiting your parasympathetic digestion so that all energy is sent towards responding to a threat. But then our other option was coming alongside our esophagus. And you should remember from vital circuitry that we had, right, both a right and a left vagus that came down, right, that had that recurrent branch that wrapped around portions of the heart and came back up to the larynx, right? We then had a right side and a left side dorsal and ventral vagal nerve. And then as we continued to progress caudally, they came together and became essentially a dorsal and ventral vagal trunk. That was basically your left and your right sides coming together to become a dorsal and then become a ventral. Those were transmitting through your esophageal hiatus along with the esophagus, and your ventral kind of ends up going more on the lesser curvature side, and your dorsal ends up going more on the greater curvature side. And then ultimately, in a lot of specimens, you can see the vagus transmitting down and joining up at your celiaco-mesenteric plexus before it then would get redistributed back down to the rest of your GI. I know that was a lot. Don't make fun of my drawings. The next time we do this, I'm going to try and make this like better animation, and we'll do this on an iPad so we can make more colors and whatnot, but I think that should be good.